Hello viewers, welcome back to our channel. In this video, we are going to be learning TCP three-way handshake on Wireshark. Okay, so I have captured some traffic and I have filtered TCP packets traffic alone. Okay, let's see the three-way handshake. We all know that TCP has to establish a connectivity before sending data. So in order to establish the connectivity, TCP has to perform a three-way handshake process. Okay, so this is our three-way handshake process. Here you can see the SYN and SYNAC, and finally the ACK. So SYN, SYNAC, and ACK. Okay, let's get into the SYN packet. Here is our SYN packet. This is our SYN packet. I'm going to open it. This is our SYN packet. Opening the SYN packet. Here you can see the source port, which is 63945. It is a random port number. Then destination port, which is the well-known port 443. So this connection is between the client to the server, which is the HTTP server. Okay, so between client and server, and the stream index. So it is the first stream. So stream index 0. So first stream. Then TCP segment size, which means segment length 0. So this segment contains 0 bytes of data. Next, sequence number, which is a random sequence number, and then the acknowledgement number, always 0 in the SYN segment. Next, header length, which is 32 bytes, because 20 bytes is the fixed size of the TCP header. The balance 12 bytes are options. Here you can see 12 bytes options. So options field has 12 bytes of data, and the window size 64240. So this is not the true window size. Next, SYN segment. So flag, SYN flag is enabled. So SYN flag is enabled. Next, window size. This is not the true window size. Next, urgent pointer 0. So this segment does not have any urgent data. Then TCP options, you can see the maximum segment size. So maximum segment size, the client is sending the maximum segment size it is going to send. Next, window scale. So window scale is used to calculate the window size. Okay, so to calculate the calculated window size. So by multiply by 256. Okay, we will see this later in the video. Next, SAC permitted. So SAC permitted 4. So which means this. So for SAC permitted 4, so which means this client can support fast transmission and duplicate acts and duplicate segments and out of order segments. So these things can the client can support. The client, if the server sends 3 duplicate acts, the client can identify that. So I have to retransmit the segment again. So these things can support. So they say that I can support SAC, which means selective acknowledgement. So these are the information, and also timestamps, which is to calculate the latency or the TTL value, the time trip value between client and the server, which is also called a round trip. So to calculate the round trip and latency, the timestamps is used. Okay, so on the no operations field, these are paddings to compensate the size. Okay, so if you see here, operation, which is 1 byte. So these are paddings. So nothing to worry about the option, no operation. Next, to go to the SYNAC segment. So let's see the information available in the SYNAC segment. Okay, so source port 443, so which is from the server to the client. This is from the server to the client, then stream index 0. So this SYNAC segment is for this particular SYN. So this SYNAC for this SYN. By looking at the stream index, we can identify this thing. Okay, then TCP segment length. is 0. So 0 means this segment contains 0 bytes of data. Next, sequence number. The server also sending a random sequence number. Okay, so this is the server sequence number. The server is starting from this sequence number. And acknowledging, here we can see the acknowledgement 73. The client sends 72 and the server acknowledges 73, which means 72 up to 72 has been received successfully. So now I'm expecting 73. So the server is expecting 73. So it is telling the client that I'm expecting 73. Then header length, which is 32 bytes, so which means 12 bytes of options are here. Okay, so then the SYN segment and the ACK segment is enabled. SYN and ACK segments flags are enabled. Then the window size 65 by 35. This is the maximum window size. So maximum size of the window size can be 65 by 35. We can increase the window size by multiplying window size by the scaling factor. Then urgent pointer 0. So this segment contains 0 bytes of urgent data. Then the maximum segment size 1440. The client sends 1460, the server sends 1440. The reason is in flight, there can be any middle router might have decremented the value according to its MTU. Next, in operation, these are paddings, as I told you. Okay, then window scaling factor 8. We already saw in the SYN segment, the client used window scale 8. Now the server is also using window scale. If any one of them does not use window scale, both cannot use window scale. So if the server cannot use window scale, the client also cannot use window scale. Okay. Then no operation, these are paddings, and SAC permitted, which is also 4. So they are agreed that both sender and the receiver, which means the client and the server can support SAC, selective acknowledgement. Okay, and the timestamps to measure the latency or the round trip. Okay, so the timestamp is mostly used to calculate RTO, retransmission timer. Okay, so these are the details available in SNAC. Next, you go to the ACK. Let's go to the ACK. Here we can see source port and destination port. So from the client to the server. So now the client is acknowledging the SYN segment. Okay, so the client is acknowledging the SYN segment and the stream index 0 and segment length 0. So same TCP connection and TCP, this segment contains 0 bytes of data. Sequence number 73 here in the SYN segment. Where is the SYN segment? Okay. In the SYN segment, okay. Okay, the SYN segment. Okay. The SYN segment 7.2, the ACK segment is 7.3 because here the SYN segment, here you can see the acknowledgement 7.3. So the server is expecting 7.3. So that's why the client is sending 7.3 because the server is expecting 7.3 now. So the client has to send 7.3. Next, acknowledgement number 58. Why 58? Let me show you. Here, the server sends 57. So the client tells the server, I'm expecting 58 because I received 57. Now I'm expecting 58. Header length 20 bytes. Then flags, ACK segment, acknowledgements. Here is the true window size. Okay, the window size 517. It's really a low window size. It is really a low window size. So this is really a small window size, 517. But here you can see the calculated window size is 132352. It's really a large window size. This is the true window size. Here you can see window size scaling factor 256. So 516 multiplied by 256. The result is the calculated window size. So the window size scaling factor is used to calculate the real window size. And the urgent point is 0, so no urgent data. And the stamps, so to measure the latency. Okay. And these are the information available in TCP handshake. So now they have established the connection. Here you can see then the client hello. So the three-way handshake is successful. Let me show you the true window size of the server. Let me show you the true window size of the server. Here you can see this is the true window size. True window size of the server 525312. 2052 multiplied by 256. The result is 525312. This is the true window size of the server. Okay, so in the sync segment, they exchange the false window size. They are not true. So these are the informations available in TCP handshake. And thanks for watching the video. If you have any doubt, please drop your questions in the comment section. There I'll be answering your questions. And thanks for watching the video. See you in another video. And thanks. Bye bye.